Mhm. 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 Okay. Mhm. 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 Hi, Stephanie. Oh, you can't hear. Just can't hear either.
Hello.
Hello. Hi, Logan.
Hello.
Hi, Ryan.
Hi. How
How
are
was
you?
it? Good. I'm in Boston.
New York was great. Uh, the weather is like 60, but like sunny, but also kind of windy. So my sweater wasn't the best thing because wind was just peeling right through it.
I see.
How's that? You're in? Where are
I'm in
you?
Boston.
Ah,
So this is a new time zone for me.
really?
Yeah, for now. It was raining a bit this morning, but it's been 60s also. Uh, we need some of their water.
Oh, you need some of our water. We've been getting like for like 3 or 4 days. We've been getting like a ton of rain.
Yeah. Yeah.
Just
Wow.
like downpours,
Okay.
but like
Yeah, we need your
steady.
water too.
You need
Um,
everyone's water.
Yeah.
yes. Have you guys sent me? I didn't look at email since this morning because I've been at a conference. This is my badge.
Oh,
Yeah. It's called the National Council of Supervisors of Mathematics, uh, and this year it's in Boston, and next year it's in San Francisco. So that's
oh, so you won't have to travel as far.
I won't have to travel. That's right. That'd be nice. But it's nice to be here. It's a good city. So,
It is.
so I wanted to know whether you had. I know Ryan, you sent me your homework from last time, and Logan, have you? What's your story?
I sent it this morning.
Okay, and the homework due today also, both because
Yes.
there was two. Okay, I'll check that out.
But there's the April 10th one, and when you opened up the
Yeah.
assignments, there was like it was labeled like 1, 2, 3, and then it started over 1, 2, 3.
Oh, did I do it wrong? Okay. Was it just a repetition?
Yeah, just the repetition,
Okay,
and
that's
like
just a mistake.
okay, yeah.
That's just a mistake. Yeah.
Yeah, I didn't.
So we had to do April 10th, and that's it,
Yeah.
right?
You're Ryan. If you did April 10th, you're up to date. It was just Logan I
Okay.
was worried about. Uh, okay, good. And journals for let's see, not for last week, I guess. Yeah, Logan, you were way behind on your journal entries.
How many are we supposed to have?
Supposed to do one a week, except for that week that every Friday, and I put it on Tuesday's assignment. I always say that, except
Yeah.
for that week that Walter was in China. Not that week because that wasn't official classes because I didn't want to count him absent. But the other weeks supposed to do it. So yeah, if you can probably see everybody else's anyway. If you look back on your homeworks, you'll see it. Okay,
We need like
Walter. I don't know whether Walter sent me anything this morning, but I'm not going to worry about it either. He'll come, or he was asking me about number of absences, so maybe he was planning on not being here today, but he should have told me. But anyway, we're just going to push ahead. Okay? So I only have one screen today because I'm in a hotel room. So
what part of Boston are you in?
I'm in the South waterfront, South Boston waterfront.
Okay.
Does that make sense?
Mm-hmm. My brother used to go to school in Boston for college. We visited a few times.
Yeah. So this is across it's the South Boston part, and there's a new convention center, a huge convention center, Boston Center for Exhibits and Conventions, something like that. Anyway, so that's where we are. I wanted to gather information from you guys on the needle dropping results. If you did that, I hope. Let me put in another. I just made this table, and I'm going to insert a row above it so I can title. Insert. Oh, table. Hello, table. Insert. Rows above. There we go. Okay. What I need is the number of successes, which means the number of times that your needle crossed the line, number of crosses I'll put. And then I need the total number, which should have been 25, total tosses. So did you, and I also need your spacing. I know I assigned it, but I forgot.
Do you need our needle length as well?
Yes, I do. Good point. So let me move that over, and I'll put another column in. Yeah, you can't see this. Maybe I should share my screen. Let me do that so that you can see that. So let me go back here, and I will share my screen, and I'll share my screen. There's only one screen now. I used to have to worry about that. There we go. So I'm going to get this up again. Can you see that now?
Mm-hmm.
Okay.
Yep.
So I want to insert that's right. This is just BlueJeans, and I'm not doing Adobe Connect, so I don't have to worry about that issue. So I'm going to I'm going to insert a column to the right, and needle length. Needle, and we don't need so much space here at all. So I'll move that over. Needle length. Okay. So
it actually took me actually took me a while to get my first. I started dropping the needle, but it took me a few like 10 or 20 drops to actually get it to where it would land on the paper.
Oh.
It would
Okay.
hit and bounce off.
Well,
I was just like, no.
The operative thing to do would have been to drop it from a lower height. Maybe you took it too seriously that I said belt height, because I hadn't really tried that. So okay. So that's what I would have done. But anyway, you got your data. So
Yeah.
So how many crosses did you get?
69.
Oh wow. How many times did you drop?
25.
Oh. You were counting, if it crossed two lines, you counted two. Is that correct?
Yeah. Okay. So I wasn't supposed to do that.
You were not supposed to do that.
Okay. Whoops.
So do it again.
I'll
Okay,
redo
wait a
that.
minute. Okay. I wasn't clear. So that just meant, yeah, okay. I didn't make that clear. Sorry about that. So
I'll send you. I'll redo the data and I'll send it to you.
Give me your spacing and your needle length.
I had a 4.5 centimeter length.
Okay.
Or, double spacing.
Double spacing, yeah. So I'll just put 2 here. And yeah, which is, it's good to know. I need to know that. So 4.5 centimeters? Right.
Needle length, yeah.
Oh, that's your needle length.
Yeah.
The spacing I can measure. I can print it out and measure it because I'm going to need that, but I can do that. Okay, so your spacing is double. I'll just put double. Okay. Logan, did you get a chance to do this yet?
Yeah.
Okay, so what's your spacing?
1.75.
1.75, thank you. And your needle length?
I can check that.
Yeah, please. Centimeters, nearest tenth of a centimeter.
Yeah.
Let's see what happened here. Let me just do no numbers here. There we go. Get my numbers correct. And I'll get the info from Walter.
4.
4.0?
Yeah.
4.0 centimeters. Great. Thank you, sir. Okay. Now, are there any questions on the pentagram handout? 10 through 16.
I don't think I did that. Can I do that? I'll do that and
Yes.
send it to you tonight. Sorry.
Yes, okay. Logan, did you do it?
Yeah.
Okay. Do you have any questions on it? Should I get it up, or are you pretty good? I'll comment on it, of course.
I think it's okay.
Okay, good. Let's discuss 3 and 4. Yeah, I'm just going to share my screen today. It's just let's discuss 3 and 4 from the inversion. So let me get that up. I didn't get a chance to do that yet. Yeah, today's 17th class. Should be there. No. Okay. It's on the previous homework then, which is the 14th homework. Yeah, that's right. But I should put it in the class also. There it is. Let me just save that for a second. Put it in there. Put it in this place too. 17th class. All right, just so I have it. All right, so, and I'm going to take out the paragraphs. Okay, so we talked about 1 and 2 last time, and I put 1 on the test, so I hope you guys got that. I haven't had a chance to look at that yet. I just got it. Because I told you I'd put 1 of them on. All right, so what I want to do, actually, I'm going to put these here. I want to get, so can you guys get up your this document that you sent to me?
Mm-hmm.
Because I didn't get a chance to get it yet. And then I just want you to tell me some of these observations. It said, use GeoGebra to experiment with reflecting lines and circles in a circle, and use the reflect about circle tool to do the inversion. So I want you to record your I asked you to record your observations, so I want you to give them to me. So as soon as you get it up, just any order, just give me the first one, and we'll go back and forth, and start with whoever gets the document up first.
Okay.
All right, so that's Ryan. You got one?
I'm trying to find my document with
Okay.
those.
Same here.
All right.
April and March 30th. Oh, here we go.
For some reason, I didn't do 3. Yeah, I didn't do 3.
Okay.
Like, I can find 4, but I didn't do 3.
Okay.
I can still talk about it, but on the
Okay.
homework, I don't think I did it.
All right. Can you give me at something? Can you
Yeah.
start us off, Logan? So I'm just gonna put Logan colon, and then here we go.
Um, the reflection of a line over a circle is another circle.
Okay. A reflection of a line is a circle. That's the way I'm going to write it. Now, is that true for any line?
No, no.
Okay. What lines reflection? So tell me the particular lines, or the conditions, whatever conditions there are that you need to
Oh,
make on the line in order that the reflection be a circle.
it goes through the center of the circle, and well, it has to. Like, yeah, it has. I think that's the only condition where it's not a circle. If it runs through
Oh,
the
where it's
center.
not a circle.
Yeah.
So here, what do we need to say? Reflection of a line. What condition do we need to put that in order that it is a circle?
Not through the center.
Okay, not through the center. Okay. And Logan, you also said, so I'm just going to put down what you just told me, which is reflection of a line through the center is
Another line.
is it a different line or the same?
The same one. Yeah.
Okay, that's important. You need to be specific. Okay. All right, Ryan, can you give me something else? Because that covers reflection of a line. And reflection of a line not through the center is a circle. You know what? Can you tell me anything, Ryan? Can you tell me anything about that circle?
If the line is completely outside of the circle, then the reflection or the image will be a circle that is completely circumscribed by the reflecting circle.
Oh, inside the circle. Okay. So if the line is does not intersect, let's put it that way. Well, is it? No, that's all right. Is outside, is completely outside, just like you said. You said it perfectly. I don't know why I was messing with that. Completely outside the circle, the reflection is completely inside. Right? Is that what you said?
Yes.
Okay. Anything else? Suppose the line is not completely outside of the circle, but doesn't intersect the center. Can we say something about what are the possibilities for the line in that case?
If it intersects at 2 points,
Okay,
if the line intersects. Oh.
Okay, let me just write it. If the line intersects at 2 points, intersects the circle. Sorry.
Yeah.
At 2 points. Yes.
Then the image will also intersect at 2 points.
Okay, which 2 points?
Oh, the same 2 points?
Huh.
I think. Or,
Yes.
Yeah.
Because any point. Yeah. Well, you tell me why. Why does it have to be the same 2 points? Logan?
oh, because. Oh, yeah, Logan.
What? Oh,
Why does if the line intersects the circle at 2 points, why does the image circle have to intersect at the same 2 points?
I don't know. I'm confused.
Okay.
Now.
Ryan?
Because inversion is since that point, those 2 points are the radius, then the image will be the exact same distance because it has to be the radius squared.
Right. Can you? Yes. Can you restate that using the phrase fixed point or fixed points?
Oh. Sorry, we just got a weird call thing going on. Any point on the circle will be a fixed point when in inversion.
Right. So I'm gonna copy that down. All righty. Is there any other possibility?
A tangent line to the circle.
Also tangent reflected.
Yeah. The resulting image will be tangent as well.
Be tangent where?
At the same point. But will it be inside or outside?
Inside.
And yeah, you had already said, yeah. Okay. The image circle will be, okay, here's a nice word.
Mm-hmm.
It'll be internally tangent at the same point.
Okay.
Externally would be on the outside. All righty. So we've covered reflection of a line, all the possible cases. So now, what about reflection in a circle? Reflection of a circle, sorry. Ryan, can you give me something about that?
Okay, so wouldn't it just be like the inverses of all the things that we just said? So like a circle that's completely outside of the circle or the reflecting circle is would also be a line outside the circle.
Logan, what do you think?
I'm not sure. Wait, hold on a sec. No,
it wouldn't be a line.
It stays a circle, but as it's like there's a certain distance from the circle at which it becomes a line. But I'm not sure what that value is.
That's just the... Oh.
Right.
So if a circle has a point, or if the circle has a point... Wait, sorry. If the circle intersects the center of
just a minute, we're assuming right now that we're reflecting a circle that is completely outside the reflecting circle.
Okay. Wouldn't that would just be a circle inside the reflecting circle?
Uh-huh. Okay, that's good. Since Logan Ryan's done a lot of work here too. Either one of you. All right, so far we've done reflection of a circle completely outside. So we need another case.
So I guess we'll go with the one completely inside.
Okay. Just a minute. I'm going to cut and paste here a little bit because I think we can just modify this. Okay, reflection of a circle completely. I don't even need to do that. Inside the reflecting circle is.
Is completely outside of the circle. So it's just the inverse of that, or
Huh?
the inverse of the first one.
Huh? Okay. Now my question is that true for all circles that are completely inside the reflecting circle?
No.
Okay, so which circles is that not true for?
Ones that have the center of the reflecting circle as
Okay.
as a point on the circle inside.
Right. Okay. So we need to modify this to say reflection of a circle completely inside the reflecting circle.
And not containing.
Yeah, that does not contain the center. Right. Does not contain the center. Okay, good. So, Logan, can we modify that? So I'm going to take this whole thing and say reflection of a circle completely inside. Oh, inside, yeah. Completely inside the reflecting circle that does, not does not, that does contain the center is what? It might help, Logan, to look back at what's above.
Oh, it's a line.
Is a line. And where is the line?
Oh, it's a Brian said it earlier, but it's a certain distance. I forgot what
No,
it.
you don't have to worry about that. The question is, does it intersect the circle, or is it completely outside?
Oh, it if it doesn't intersect the circle, then the line doesn't intersect also.
Okay, so it's completely outside. Good. And we have one more case. Either one of you. So one more case of reflection of a circle. We've talked about a circle completely outside. We've talked about a circle completely inside that does not contain the center. We've talked about a circle completely inside that does contain the center. Maybe I should underline this and this to focus that. Okay, so what's the remaining case? There's only one.
Where the circle intersects.
Okay.
The
actually, there are two.
Yeah.
So, reflection of a circle. Let's just take this much and change it. Reflection of a circle that intersects the reflecting circle. What do we need to say now?
That.
There are two types of such circles.
Yeah. There's a tangent. There's one that's just a tangent, and then one that intersects twice.
Right.
The one that intersects. Oh yeah.
Go ahead.
Oh, the one that intersects twice. That would be a larger circle that intersects at the same spot, or same places.
Okay, good. There's another circle that intersects the reflecting circle, same points. One more case, Logan.
If it's tangent if it only touches it at one point.
Right. So let's do that. Reflection of a circle that intersects the reflecting oh wow, what did I do here? That intersects the reflecting circle. I repeated that. Didn't have this problem. Is that right now? Reflection of a circle, reflecting circle twice. Yes. Reflection of a circle that intersects the reflecting circle once.
I do that all the time. I retype what I've just written. And...
Yes, right. Cutting and pasting gets you in trouble. So I'll say tangent is another circle. Logan, finish it for me.
That is also tangent at the same point, or yeah, that.
Same point.
With the tangent ones, do we have to specify internally and externally?
Good question. Do we?
I think so, because if the original circle is internally tangent, then the result would be externally tangent.
Okay, let's
And
put
then
that.
vice versa.
Right. If original is internally tangent, image or pre-image. Let's use that. Are nice words. If pre-image is internally tangent, then image is externally tangent, and vice versa. How's that for a shortcut? Okay?
Yeah.
We're complete. Excellent. Okay, so
is there another one for a circle that intersects the reflecting circle, but it also contains the center? Because wouldn't that be a line that intersects at the same points?
Good for you.
Right.
Good for you, Ryan. I missed that. Let me do this right. Sure. Very good. Thank you. Wow. Impressive. Okay. So say that so I can write it. Reflection
of a circle that intersects is a line that
intersects the reflecting circle, let's say. Reflecting circle, go ahead.
And contains the center of the reflecting circle.
Right. Intersects the reflecting circle twice. And boy, there's another case too. Holy cow.
Well,
intersects the reflecting circle twice, and I'm sorry, go ahead.
Couldn't we just leave off the twice, because wouldn't that account for the other case as well?
Maybe so. So reflection of a circle that intersects a reflecting circle and passes through the center. Its center. Go
on. Is a line that intersects at the same, or the reflecting circle in the same spots.
Okay.
At the same points.
Yeah. Good for you.
Because if you have a tangent circle that intersects or that also contains the center, it would just intersect at the same spot, so we wouldn't have to put the 2 points.
Mm-hmm. Right, you are. Good. Okay. Yeah. Is there anything else? Did we leave out anything?
There's also a point where the reflected circle is overlapped with the reflecting circle, like the image to the pre-image. I mean,
The image and the pre-image are the same, I guess.
Yeah.
Uh-huh.
I'm not sure how to
Yeah.
how to describe the distance though.
Let's just say this. There are cases where the image, where the pre-image circle, and we can use some nice vocabulary here. Pre-image circle is a what? 2 words.
Uh, an identity.
Almost.
Oh, fixed point.
Not quite, because we're
Invariant.
talking
In-
about a set, not a point.
Invariant set. We did it.
You did it.
And isn't there another point where if the center of the circle, if the center of the circles match up, do we have to mention that?
Oh. Wow.
Oh.
Yeah.
That's good.
No, that's good. That's good. That's good. Boy, you guys are cooking with gas today, as they used to say. You know where that comes from? Cooking with gas. That is. Yeah. Go ahead.
I'm gonna guess that's like
Gusto. Like.
when they switched over from wood stoves.
Yeah,
I don't know.
Right. Exactly right. Exactly right. When gas stoves first came on the market, that's what they said. That's right. And there are so many things that don't apply anymore, but originally meant something. But we still use them because people are just used to it. Now, here's another one that nobody knows. Mind your P's and Q's. Have you ever heard of that?
Yes. I don't know where it
Mind
comes
your
from though.
P's and Q's. Be careful. Where did that come from? Do you have any idea?
Is that when we still used a lot of cursive, or is it something else?
No. It's a great story. This is like 16th century, 17th century England. And at that point, when you went to the bar to have some drinks, you would usually order ale, and you could get ale in a pint or a quart.
Oh.
This is true. And you had to keep track of your bill. It wasn't like, you scan this, you come up. No, you just were drinking all night, and you had to keep track of your bill so you knew how much you didn't collect money every time. You collected money when you were done and you left. So you needed to mind your P's and Q's so you knew how much to pay the bartender.
Yeah.
That's funny.
That's the real story. Okay. So, you just said something very interesting. And there's a nice word we can use here. If the pre-image and reflecting circles are, what's that nice word? We talked about the same center. There's a nice word for that.
Co-central?
Almost.
Concentric.
Concentric.
Nice.
So if they're concentric, then
it's if then the image then the reflection is concentric as well,
yes,
or concentric. Sorry.
the image and reflecting poles are also concentric. And we could say if one's inside, the other's outside, but we know that. Okay. Anything else? Did I leave out anything else? I was leaving out a bunch of stuff.
I don't think so.
I don't
Unless
think so.
Walter finds something.
Yeah. I thought we were done a while ago, and you guys saved me. Thank you. Um, all right. Any quest? Did you have trouble with 4, or were you able to do it? And so what the rest of the sheet is about, and I didn't include all the cases because I didn't realize there were so many.
Oh no, we made more homework for ourselves.
I don't know if I'm going to add, but we wanted to prove these. So this is the proof of one of the things you said. So the image of a line outside the circle. So that's reflection of a line not through the center is a circle. If the line is completely outside, the reflection is a circle completely inside, because we said is a circle. Let's make that clearer. Is a circle completely inside. So this is an attempt to prove that first thing. Were you able to? Is it just a matter of my looking at your homework? Were you able to do it or not?
I think so.
Okay. Okay. If you think so, that's fine. I'll then look at your homework. I guess I just want you to tell me if you couldn't get started at all.
I tried, but now I know how to do it.
Okay. Good. Okay. So Logan, you can now since you said now I know how to do it, it would be nice if you would send me that.
Yeah.
Okay. I'll make a note. All right. So that's it for this. And we've done number 4, and we have 20 minutes left. I wanted to work through some of this, but this I don't think will be too tough because of the instructions are pretty clear and it's kind of fun. Help students with page 46, exercise 4, if you needed it. So let me get that up. I can actually just here. So page 46, which means I have to go to 50 on the pages in the document, I believe. Yeah. I should have said 46. Why did I? Yeah, here it is. I should have said page 47. Did you realize that? Sorry about that.
Was this the shuffleboard problem?
No. This is the spaghetti. This is the spaghetti problem.
Oh, I did the police officer one.
We're doing page 46. Wait.
Yeah,
I meant 47. I'm sorry. It's my fault. Okay. So did you do 3?
Yeah.
I did it as well.
Okay. So you both did 3. Okay.
Yeah.
Fair enough. I do want to. You get credit for that.
Wait.
You know what? So what I'll do, I posted the homework already, but I'm going to change it. I'm going to assign 4. So let's just make sure that you can get started, because this one is really interesting. So it says if you break a piece of uncooked spaghetti into 3 pieces of random length, what is the probability that the 3 pieces will form a triangle? So I want you to think and talk with each other. That's a good thing to do for 2 minutes, and just how to get started. Well, that's all I'm interested in is how do you set this up? How do you get started? How do you define your variables? And what conditions are there on the variables? That's all I'm interested in, nothing else. And while you're thinking, I'll fix the homework.
Okay, so
So like the three pieces would be like A, B, and C, right?
Yeah.
And then
Let me interrupt you for just 1 second.
oh,
We're talking about problems in the plane right now. This can be done that way, and I'm going to assign that later in 3 dimensions. But right now, I want you to try to do it. Since these problems we've been doing are in the plane, there are only 2 variables.
Okay.
Okay.
yeah, and then
Because if we get one of the lengths a constant, then we can just work with the 2 other side lengths.
it would be like one
then-
side minus the constant.
Yeah.
Yeah.
Maybe.
So weird.
Because, like, thinking, when you just set it at, like, it doesn't have to be a right track.
Yeah.
Throw out all that.
Yeah.
Would we just be, like, assign them, like, X, Y?
And then the constant.
Yeah. Would we set it up to where, like, we get, like, X plus Y plus the constant is equal to, like, the original length,
Yeah.
whatever that was.
Let me say one thing. Does it matter how long the spaghetti is?
No.
Not necessarily.
Well, is it not necessarily, or is it no?
No. I'm gonna go with no.
I'm
We're gonna go with
not
no.
sure.
Okay. Yeah, because everything's similar. So that means that you can pick a convenient length for the spaghetti. You can pick whatever length you want, and you'll always get the same answer. So choose a length.
3.
Instead of having another letter, just choose a length.
This is the original length of the spaghetti?
Yeah.
Okay, so 10?
Okay, 10.
Because, like, 3 would be hard.
Yeah, especially since they'll be different. You get decimals. I don't like decimals.
Yeah, okay, we'll pick 10, I guess.
Yeah, 10. 10.
So, could we also give one of the broken pieces a given length, and then work with 2 variables for the other 2 sides?
What do you think, Logan?
Well, yeah, that's what. Yeah, I'm with him. Yeah, like that's what we were thinking of doing.
Okay. Suppose your one piece has a fixed length of 2,
Yeah.
right?
Uh-huh.
And then the other pieces are X and Y. And your whole length is 10. Then there are restrictions on X and Y, right?
Mm-hmm.
Yeah.
But you don't want restrictions on X and Y.
Okay.
So I don't think that works.
Okay.
So I think your idea of having the whole length be 10 and the 2 of the lengths being X and Y, that's a good idea. Can you now express the third length?
Oh. Can we express it as 10 minus X and minus Y?
Yeah, sure. Okay. So you've expressed the three lengths, and then you need conditions. Yeah, how do you decide whether it makes a triangle? In
Two
general,
sides. Oh,
how do you decide? Suppose the sides are A, B, C.
two sides have to be less than the third side, right? Or something along those lines.
Something along those lines, yes.
um,
Just say it in terms of A, B, and C.
Oh. A plus B is less than C?
Okay. Ryan, agree?
yes.
So suppose C were 8 and A was 1 and B was 2. So 1 plus 2 is less than 8. So you're saying that a piece of 1 and 2 and 8 make a triangle.
No. Oh, okay, so it has to be.
So are we just trying to figure out
Just
how we're gonna?
ABC. Just give me an inequality. Logan was close, but he said A plus B is less than C, and I gave a counterexample.
Maybe we have to do the left hand, or like we have to like it has to be more and less than something.
Oh, like a 3 thing.
Yeah, yeah.
It's one inequality is all you need.
Never mind, just one.
Um. I have no idea.
Okay.
Will we just switch around the letters then?
Okay, so what would it be, Ryan?
What was the first one?
A
Said A
plus
plus
C.
B less than C.
Would we do it for just all three, or?
No, he
Well,
said.
Or
let's
just
just
one.
do one first. Just give me one first. Yes, you're right. You do need it for all three, but let's just do one first.
So could we just say like A is less than B?
Logan?
A plus C is less than B.
A plus C is less than B. So, in other words, you're saying the sum of two sides is greater than the third side. Does that have to be true?
Or it has to be less than the third side.
You just
Or-
said
no.
that. I gave you a counterexample of 1, 2, and 8. So 1 plus 2 is less than 8, but you said, can you draw something? What has to be true? If you have one side of 8, then draw the other two sides and tell me what has to be true of those other two sides. So suppose one side is 8. Draw the other two sides.
So we have
2 and 8. Wait, so A plus B has to be less than C. B plus C has to be less than A. And then C.
Well, you
plus
keep saying
A.
less than, and I gave you a counterexample for that.
But
So it has to be greater than then.
Yes, it has to be greater than. because you're going a longer distance.
Oh, okay.
Yes. So the sum of two sides, complete the sentence. The sum of two sides of a triangle is?
Greater than the remaining side.
Good.
Okay.
So how many inequalities are we going to get from that, Logan?
3.
3, yes. Okay. You now know how to do the problem. So that's the setup. And I was going to assign the three-dimensional version, assuming you did the two-dimensional version, but you haven't. So I'm going to change. So right after this class, I'll change the assignment and have you do the two-dimensional version, which is exercise 4, and I'll give you the right page this time. Okay. Now, the last thing, because we got like 6 minutes. Where are we? Tuesday class. I was way ahead of myself. Here we go. I made a document called Matrices in GeoGebra that I got from, I modified one of Henry's once again. So it's in doc sharing in both the class, today's class, and today's homework. So you can get it from either place. And so download that now. You know what? Don't download that now. I'm just going to get it up and just show it to you because we're running out of time. So.
The matrices thing took forever.
Yeah.
So let me get that here. For 14 homework, it'll be there. Yeah, this one. Okay. So what this document does is tell you how to make matrices in GeoGebra. So I'll just spend a little time giving you the outline and just work it through. I mean, it's not a big deal. So this first part tells you, are you familiar with the input? I said bay. I meant bar. So when you open GeoGebra, let me just show you this. When you open GeoGebra, you have these perspectives or panes on the right. And we've been using the geometry pane. And when you use the geometry pane, it looks like this. And there's no input bar on the bottom. But if you go into the algebra pane, then there is an input bar. And there is a set of axes. And under graphics, if you open that up, you can make a grid if you want. And you can move things around, and you can change the scale by going up here if you want to. If you go to graphics, you'll have opportunities to change those things. But the input bar is down here. And so you need to know that. And you need to be in the algebra pane to do that. And so it says bottom screen about an algebra view. And you enter a matrix in kind of an awkward way. So this tells you how to open it, and you have to use curly braces a bunch of times. And when you put in a beginning curly brace, it automatically puts in an ending curly brace. So you kind of have to be familiar with that. So you start off with 2 beginning curly braces, and then you just enter it. And you enter it row by row. So this row is 1, 0. It says that, so you'll get used to that. But after you go through that and you check that the multiplication gives a result, I was pretty clear here, so just go slowly. Also, if you want to use something like sine 56 degrees in a matrix, you just enter sine 56 degrees like this, and you don't have to get a decimal. You can just, this is the exact value, but you do have to use the degree symbol, and so it's important that I tell you that you get the degree symbol by Control O. Okay, so Control O is the degree symbol. But obviously that's tedious. So you can also enter a matrix in spreadsheet view, or they call it perspective, but I'm just going to call it this. So there's a spreadsheet choice here. And if you pick the spreadsheet choice, it gives you a spreadsheet. Nice. And once you enter stuff in it, I'm just going to enter a 2x2 just with random numbers. I want to show you that once you do that, if you select the whole thing, oh yeah, it was there already. There are new tools. This is one variable analysis, but this is the tool you want, the list tool. And in the list tool, there's the usual thing you're used to, the arrow, and there's a create matrix. So you're going to use that create matrix down here, and that's going to make a matrix for you. And it explains that in some detail here. And it tells you, it just leads you through it. So there are 4 problems there, and let me just see what I assigned, and we're just about out of time, but let me just see here. So we were going to work through as much as possible in class, and the answer is we didn't do very much, but I did give you what you need. And so I want you to finish, or in this case, do that sheet. So there are 4. That's one part of the assignment. And it's time, right? So I think we did it. And what I'll do is I'll send you the result of number 3 that we did in class today.
Okay.
That was in that document that I got rid of. But anyway, that was in the inversion document, number 3. So instead of sending it to you, I'll post it in today's class, the new version. There we go. That's a better idea. All right. Okay. We are out of time. Next time I'll be home. So we'll see you guys. Have a good week.
Have a nice day.
And have a nice day.
Have a nice trip, too.
Thanks. Take care.
Bye.
Bye.
Bye.